Just opening up the monitoring well. Sometimes some debris, some soil gets in the hex inserts. It's nice to have a little pick or small screwdriver to clean out soil and debris. Open up the lid. Next thing we're going to do is a well verification. Going to use the solid water sounder to measure the depth to static groundwater level and also the total depth of the well. So I'm just going to unscrew it and take out the plug. And we'll make our measurements to a common data point. The data that I have that has been surveyed is to the south side of the 2-inch casing, which in this well is in this direction. So again, make sure your saltness is working. Put the sensitivity all the way up. This probe has already been decontaminated, so it's fine to put in this well. So we always want to be careful not to cross-contaminate our wells. So we'll just lower it in carefully to get a depth to groundwater. Again, the measurement is to the top of the casing, not to the top of the well. Dip it a couple times. So in this well, it's 2.7 meters to the water level. I'm just going to turn off the meter right now. I'll just continue running in the probe just to get a TD measurement. Just going gently. There's no point in ramming down. The well isn't that deep. And damaging the equipment, damaging the probe. Okay, I've hit bottom. Kind of come off it, on and off it again a couple times. Just get my reference point here. It's 8.11 meters. Okay. So we're going to come all the way out. You can wipe off the tape. Try not to twist the tape too much as well. Just dry it off as they come up. It's kind of hard for me because I'm by myself today, but if you have someone to rinse it off with DI water, distilled water, that would be good. Otherwise, what you'll have to do is do a triple rinse back on the surface. So I just have a little DI water bottle. I'm just going to squirt it off. Ultimately, it'd be nice to do that with the whole tape. Again, what we always want to do is avoid cross-contamination. Okay, tighten the nut to the reel so it doesn't backspool on you. Turn it off to save batteries. And what we're going to do next is deploy our data loggers in preparation for a slug test. This well is MW17-08 on the middle to western side of the AB parking lot. So when we're doing our slug test, you can do it several ways. You could do it the way that we're doing right now or the way that's in the video. You can do it manually or you can do it basically automatically with the data loggers. So I'm going to do it automatically with data loggers. This is a Schlumberger mini diver baro data logger. This is not meant to get wet. It just measures ambient normal air pressure. If you're doing a long-term monitoring, what you can do is you could actually cable it and you could have it hanging in your well with maybe another data logger as well. And what we're doing is barometric compensation. We'll talk more about this in class. But the data loggers work, it's a piezometer, works on a change in pressure. And the change in pressure obviously is influenced by ambient air pressure, and we know that air pressure changes, throughout the day, as you see on the news forecast, weather forecast. So if we do a barometric compensation, basically we're going to have a measurement of ambient pressure right at the well, and we could use that correction applied to our downhole data to get true pressure data that we're going to interpolate into a water level measurement. You don't have to have one of these kind of hanging in every well. In fact, in this slug test, it's only going to be maybe a half an hour or an hour. We'll see how it goes. So actually, I could actually just have it on the ground, or you could really just kind of have it with you or on you, measuring the air pressure. And if you have one of these measurements, as I go around and do various slug tests throughout the campus, the data from this barometer will be can be used for all other wells, as long as it's within about 15-kilometer radius. So instead of just putting it in the well, there isn't much room here. I'm just going to set it off to the side. It currently is reading ambient air pressure. So what I'm going to do is get my mini diver that's going to go into the well bore, and then I'm going to insert a slug, and we'll continue with the process. Okay, here's the cable that I'm going to run on the diver. You'll see that it looks exactly like the barrow. They're just stamped differently on this side, and of course they have different serial numbers. I know that this well is just over 8 meters deep, so I've already pre-cut this cable to be 6.67 meters. So because we're just monitoring the change in static water level when I introduce the slug, this does not have to be on the bottom of the well, nor do you want it within the top where it's going to interfere with the slug. So I have it designed so it's going to sit about 1.5 meters off bottom. And again, I'm just going to slowly lower that in the well. But what is interesting to know is how much cable that you are deploying, because that is a data input into the software. You want to use a metal cable here. You want to be careful not to kink it. You want to use a metal cable because the metal cable won't stretch. This is aircraft wire. You can see it kind of bunged up on me a little bit. So I know that from my measuring point on my data logger, which I know this is a barrel data logger, but they have the same geometry, is right to the top of the bottom cap that covers the pressure transducer. So I've already pre-measured that. I've indicated the depth on the tag, and for my measurement, I made it right to this little pinch point right here. And again, that's going to give me 6.67 meters. Okay. So what I'm going to do is I'm just going to hang it off to the side. When you take off the well cap, you're going to see there's a couple places where you can just anchor off points. And right now, I know you can't see it, but it's hanging. Okay? And I'll give you a picture of it later when I deploy the data logger on the well. So the next thing to do is to introduce the slug. We're going to do a falling head and a rising head test. So first thing is to take the slug, to deploy it quickly into the water. What's going to happen is the water is going to increase to a certain height based on the displacement volume, and then as the water level equilibrates, it's going to come back down to static water level. And actually right now our our data logger is capturing pressure data right now, so it's nice to give it kind of a couple minutes of kind of baseline data, pressure data. So I'll give it some time while I'm getting my slug set up. And then what we're going to do after we introduce the slug and we get the falling head test is quickly I'm going to pull out the slug, and what's that's going to happen is as I remove that displacement, the water level is going to drop, and then it's going to rise again. So we're kind of getting a 2-for-1 test, and whether it's a falling head test or a rising head test, it'll be nice to compare the data. They should be about the same. So we're getting a 2-for-1 test in doing it both ways. Okay, so here is my slug. This is a pre-made slug from a manufacturer. You obviously have to make sure that the outer diameter of the slug will fit within the inner diameter of the well, and we're dealing with a 2-inch well. So that's obviously important. So this type of slug doesn't have to be bought externally. You could just take some PVC, fill up with rocks or some cement, anything that causes a displacement. It'd be nice to ultimately know the volume that you're displacing. But again, it doesn't have to be a fancy slug. What is important too is that you tie it off really well, and you don't want to drop this and have it fall down the well. So it has some significant weight to it. So what I'm going to do is I'm going to basically introduce it into the well, and the data logger is capturing data right now, so let's see what happens. And that's why it's nice to have the data logger significantly below this slug so we don't get a collision. Okay, so I have buoyancy, and I am just going to tie off my slug here and let it stabilize. Okay, so I'll think about what's happening is I've introduced the slug, the water level is coming up, and now I have to give it time to come back down. So I'm kind of blind here. This type of data logger allows me to not get the data directly. To get the data, I'll actually have to pull it off and put it into a docking station to download the data. Some data loggers aren't like that. They actually have a cable attached where you can get a digital readout right away. That's not the type that I chose to purchase for a educational environment, because I would rather have more data loggers for all the students than to have fancier data loggers and to have everybody look over each other's shoulder. So what I want to do is, with that kind of safely tied off, is now I can bring my water level meter back, right, my Solinst, and now I'm going to monitor basically the fall of the water level, and I should be back to where I started, which was 2.72 meters to get equilibrium. Once I've established that, then I'll continue pulling out the slug and then watch for the rise in water level. Okay. So again, the depth of the same reference point. Okay, so right now the water level is at 2.56 meters. So it has raised with the displacement of the slug. And now we'll just kind of keep on monitoring it until we hit the static water level. This is where we wait. It could take some time. If it's very, if it has an aquifer with very low hydraulic conductivity, very low permeability, it can take some time. The static water level for about 15 minutes has remained unchanged. And that's a good thing about slug tests, is you don't necessarily have to wait all the way for equilibrium. It looks like we're at about 2.57 meters, so it's pretty interesting well. As I'm characterizing some of these wells, I'm trying to get a feel for some of these different wells. So as I was saying, the computer can extrapolate based on our response. So I'm just going to go ahead and just pull up the slug really quick, and I'll see the static water level decrease, and then that'll give me a comparison. So you want to make a note in your notes what time that you introduce the slug. Pull this slug, of course you're going to see that very clear on your pressure reading as well. All I'm going to do is just yard it out as fast as I can. You want the response to be instantaneous. So obviously it was in the water, it's dripping wet. Okay, and now remember our data logger is still collecting data. So that's good. As I've pulled out this slug, the head now is going to be rising to account for that loss of displacement. We'll monitor this until we get back to static water level. Okay, hopefully you'll be able to see into the wellbore. There's my barometer just sitting there. Again, if you wanted to have it in your wellbore, what you could always do is you could have it and anchor it to this eyelet, or you could always anchor it to the bottom of the well cap if you had a clip. Again, we want to make sure that this doesn't get wet. In truth, it could survive about 1 meter of water, but the best practice isn't to do that. I have my measurement point right to here, to the bottom of this clip, and I already estimated that was, well, I measured 6.67 meters. Okay, so what we're going to do is, before we pull out of the data logger of the well, we're just going to take a water level measurement again and see how close that we are to static. This again was MW 1708 with a static water level of 2.72 meters. My probe here has been decontaminated from the last well. Let's see how close that we are to a static water level on removal of the slug. Remember, our pressure transducer is still reading. Just want to get a measurement right here. .72 meters. Good. So we've established our static water level once again. So it will be a successful slug test. So now I'm going to decontaminate my water level sounder, and quite simply, set it aside for now, I can go ahead and pull out the pressure transducer. Of course, that'll have to be decontaminated as well before we go to the next level. And right now, it's reading every second. It's reading ambient temperature. It's reading temperature and also pressure. Okay. So I could remove the anchor clip from the well cap. Set my cables aside. And make sure that the surface here, this sort of sealing surface, it's a metal surface, so does get some debris. Some of them have rubber rings that you'll want to take out before you put an iron brush on them to clean up. But we're going to put our well cap back on, our tensioning well cap back on, and screw it so it's snug. You don't have to get uber tight on it. And then we're going to put our cap back on here. Okay. And again, too, you don't want to strip out these hex nuts, these hex bolts. So we're just going to hand tighten them first of all, and then just give them a bit of a turn with a wrench. But we don't have to get crazy on them, or else we'll be fighting them forever. And that'll be it for the slug test.